Next, we're going to talk just briefly about calculating rates in epidemiology. Nothing you need to memorize or know, just to give you a little bit of an idea of um, how they come up with their numbers and how that affects how programs and treatments and risk factors are calculated. In epidemiology, we cannot stop at simply comparing the number of cases. We also need to compare the rates. Rates really help us to look at the health problems among different populations that include two or more groups who differ by a certain characteristic. For example, we might compare persons who had not eaten at a particular restaurant for a particular meal with persons who had eaten at that restaurant for that meal to look for cases of foodborne illness. Or we might compare men and women, see how often they display a certain risky behavior, say, for instance, driving intoxicated. By comparing these population characteristics, we can then observe more carefully what factors might be associated with a health event, such as what might be making persons ill. We can then determine what actions to take, such as facilitating programs and activities that support health or prevent more persons from becoming ill. So, how do we calculate a rate? We first need to determine the frequency of the disease, which includes, as you can see here, the number of cases, the size of the population that's at risk, and the period of time in which we are calculating the rate. After the frequency of that disease is identified, the illness rate is calculated by then dividing the number of cases of disease for the selected time period by the population at risk. This formula provides the number of cases as a percentage of the population in a given time period, and that's really what we're looking at. And you're probably thinking, well, why do I need to know that? But there actually is. Let's look at an example of how these rates were calculated in an actual case of unexplained pneumonia. So, members of the American Legion gathered for the annual American Legion Convention in Philadelphia. And soon after the convention began, a large number of attendees were admitted to a hospital emergency department, or they were seen in doctor's offices with an acute onset of fever, chills, headache, malaise, dry cough, and muscle pain. There were actually 18 deaths reported among the conventioneers. So that's pretty scary and pretty significant. On the morning of August the 2nd, a healthcare provider at a veterans hospital in Philadelphia called the CDC to say, hey, something is going on. We're getting a really serious respiratory illness among these American Legion conventioneers. What's going on? That same day, there was an additional 71 cases reported. So this was a pretty significant thing that happened here. These cases of unexplained pneumonia were investigated, and subsequently they were given the name Legionnaires' disease because of the association with the American Legion Convention. This chart kind of shows how the CDC investigators focused on a particular hotel as the possible source of the outbreak because there was a common factor among the ill men. The investigators wanted to find out if any trends existed by age group among the hotel guests who were ill. Here you can see the three elements that constituted the epidemiological rates. We're looking at how many were sick, how many were in each age group, and then, of course, what was the time period we were looking at. We can calculate the rate at which each group became ill after staying at or attending a meeting at Hotel A during the convention by using that basic formula. So among which age group did the largest number become ill? Well, as we can see, we had 320 persons and 27 people became ill from the age of 50 to 59, and they also had the largest number of people. Which age group had the highest rate of persons becoming ill? And if you look at that, that's actually the older individuals who were greater than 70. So that's one way that you can look. You can see how by looking at those rates, that kind of gave you a little clue. Initially, you might have thought that the age 50 to 59 was had the highest rate of illness, but it was actually the older population. And that kind of lets you know that while they were all exposed to this Legionnaires disease, that particular population, for whatever reason, was at higher risk for contracting the illness. Next, we're just going to look at some approach and methods in epidemiology. We're going to look at experimental and observational studies, and this will just be really quick. Oops, flipping around. Let's examine the different types of epidemiological studies. In an experimental study, the investigators can control certain factors within the study from the beginning. An example of this type is a vaccine efficacy trial that might be conducted by, let's say, WHO or the National Institute of Health. In such a trial, the investigators randomly control who receives the vaccine and who doesn't receive it among a limited group of participants. Then they observe the outcome to determine if it should be used more widely. In an observational study, the epidemiologist does not control the circumstances. These studies can be further subdivided into descriptive and analytic. Descriptive epidemiology is the more basic of these categories, and it's fundamental to what epidemiologists really do. Oops. In descriptive epidemiology, we're looking at time, place, and person. Another way of comparing descriptive and analytic is to say during the descriptive process, we're concerned with when were they affected, where were they affected, and who was affected. From the observations gathered during the descriptive process, a hypothesis is generated about the causes of observed patterns and the factors that increase the risk for disease or injury. To test a hypothesis, then epidemiologists have to look at an analytic method. And then they have to find out why and how the population was affected. So how was the population affected and why was that population affected? And you can kind of see this. For instance, epidemiologists are really more like detectives. And you can only imagine when HIV first came on the scene, there was a real scramble to figure out what was going on. And it was through these careful, first, descriptive epidemiology. So when was this population affected? Where were they affected? Who are these people getting HIV? And then we had to go a little deeper, and they had to really dig in. Why was this particular population being affected? How was this being passed in the population? So descriptive and analytic epidemiology really is detective work, digging into what's going on. So let's look at just a brief example. And I thought this was so interesting that, this was the example they came up with. I was like, tractors? In 1982, the number of farm tractor associated deaths, this took place in Georgia. An epidemiologist in the Georgia Department of Public Health became really interested in the number of deaths associated with farm tractors. He determined he could examine this problem by using readily available data, death certificate records that were included in an existing surveillance system. And he obtained these death certificate records for all deaths that occurred in Georgia from 1971 through 1981 that were associated with farm tractor incidents. I thought this was interesting because this is the period of time. During this period of time, I was actually right after this working up in Northeast Georgia in Gainesville, and I kept saying I'd come home. I worked in a surgical, medical ICU. We did have lots of trauma, and I kept coming home and say, wow, we have so many tractor accidents up here. And I didn't realize they'd actually studied it. So after this guy collected the data, he used the information to describe the problem in terms of time, place, and person. And then he kind of came up with a hypothesis for further study. So let's look what he found out. So this graph describes the when for those 166 of the farm tractor associated deaths. We can examine that data by looking at the time of day when the deaths occurred. So when you look at this, you're looking at the number of deaths, and then we're looking at the time of day. And so what kind of inferences can you make by looking at this? Well, there's 2 times a day that seem to have the highest number, be the most likely for people to have an accident. And that's between 11 and 12 and between 4 and 5. So they occurred right before lunch and during late afternoon. In addition, the lowest time for these accidents, other than, in the middle of the night, was during lunchtime. So this graph describes the who. It indicates the number of deaths by age group. So what else can you infer by looking at this graph? Well, we can see that the highest number of deaths occurred in those aged 60 to 69. And I would say, just from my time in that intensive care unit, I would concur that most of the bad accidents that I saw were people who were retired. So by analyzing this data, we discover which age group is at greatest risk for farm-related incidents. This map describes where. It indicates the number of deaths by county or the places in Georgia. These are the highest number of deaths, and these in fact were in the region in which I was working at the time. So what are some possible explanations for this geographic distribution? We might say this is a more mountainous region, and so you might infer that the rugged terrain is responsible for more tractor-related deaths. And that makes sense because we certainly know that in South Georgia there are plenty of older gentlemen on tractors. However, the landscape is flat. Whereas in North Georgia you had a lot of hills and rocks. I often would have a patient who had been in a rollover accident with a tractor. The tractor had fallen. So that's just some things you can infer by looking at those statistics. So we'll just pause now, and I hope this isn't too detailed for you, and come back shortly for just a little bit more information.